I think we should start the session. I think maybe slowly they are joining. Okay, guys. So today, let me on my screen, guys.
Kama nafikiri wacha mimi nitalifanyia kazi tunapotokea kwa solution. Sasa hapo unaweza kuifanyia sasa hivi halafu
I think still people are joining. See, not yet joined completely. So let's see. Okay, so can we start the session, guys? Because still people are not yet joined. I don't know why.
Thanks, sir.
Because I shared in a lot of other group as well. Okay, guys, so today I'm going to discuss these things. So before I could start, so let me start it down. What are the topics I'm going to discuss in the switching part? The first thing we'll start about basics of switching. Okay, the second thing is we shall discuss about STP. You know STP? You heard about STP, guys? Right. Then we'll go for PVST. And RSTP. Okay, so we are DR and BDR election. VTP. You can see my screen, right, guys? All of you? Isaac? Yes, right? So this is the topic which I'm going to discuss, guys, for the switching part. And VTP. And we'll also discuss about inter-VLAN routing. Okay, so router on stick. Then we'll do inter-VLAN routing with separate link. You heard about spanning tree, guys? All of you? Anybody? So this is the topic which I'm going to discuss in another next week, guys. Okay, so these are the topics like which I'm going to complete in next week, guys. Okay, today is Saturday, right? Okay, Saturday, Sunday. I think today is the 1st April and tomorrow is the 2nd. I think next week might be your 7th and 8th April. That is same on Saturday and Sunday. So I'll be completing these all topics, guys. Okay, the topic one thing is basically that is, as I told you, that IPv6. Okay, IPv6, which I am going to discuss maybe tomorrow. We shall discuss, because switching is quite very important than routing, because switching will be handle a lot of work. Well, if you are a network engineer, so we can find most of the work in switching part, not the switching, because every day you cannot go and configure your routing and switching, right? Correct. Once the communication is done, so there is no job for any routing. Just we need to monitor the network. So most job will be in your switching, guys. The most job you can find in only switching part. Any idea, guys, about switching? Anybody have any idea before I could start the session? These are the topic, guys, which I'm going to discuss. Okay, so let's start with discuss with these guys. So actually it is your layer through switching, guys. Right now we're dealing with the layer through. That is your data link layer. Okay, switch break up large collision domain into your smaller ones. Collision domain network segment with the 2 or more devices share the same bandwidth. Okay, so your layer 2 switches is work on your data link layer. That reason we'll call the layer 2 switches. So one of the example has given hub network, the typically example for this type of technology. So each port of the switch actually is a one collision domain. Okay, each port on your switch is a collision domain by itself. So it will be used especially for Ethernet LAN network, just replacing with the hub to the switches. So if you talk about the switching services, so it gives us services like we can see specific integrated circuit like layer 2 switching, bridging faster than your routers. Remember, the switches are very faster than your router. Okay, the reason because here is they don't take up the time look up the network layer header informations. They look at the frame header, that is your frame hardware address. The frame hardware address means what, guys? What is he is addressing to? He is addressing to for your MAC address. He is addressing to your MAC address. Okay. And decided whether you want to forward the frame or drop. So remember, so as you know that switchings you will be work based on your frames, not your packets. So packets, the PD will call it in your data link there, correct? In your data link layer. So later so efficiency, that is no modification data take place while delivering your frames. You see, it won't do any modification of your data. Okay, same thing what is talking about, like we can see bridge and switch learn the following. So receive the source MAC address of the each receiving frames or data link. So recording of the port on the each MAC address are received. Okay, you know what is talking about? It's talking about like let me show you the one very good example in coming slides. Yeah, so let's start with this thing, because if somebody is talking about how the switch will do this example, is talking about, see, we can see Ethernet access the hub. Okay, are you familiar with the hub, guys? All of you? Guys, are you familiar with the hub?
Yes, we are familiar with.
Okay, how your hub works, guys? Any idea?
It transfer data between
If
devices, but does not keep memory of the process.
But if I ask, like, how do you differentiate between hub and switch? Means, how do you explain?
Switch has address table, but hub doesn't have an address table where it keeps memory and track of the movement of data from one node to another.
Okay. See what I'm trying to explain here. See, both works are the same fashion. There's no difference, guys. Suppose if we talk about only one major difference, suppose this is your switch. Again, this is your hub. So as you know, the hub is look like same like your switches. We'll be having a lot of ports inside, which is connected. Okay. These are the ports. So maybe you connect some end user devices. And here also we'll connect the end user devices. The problem here is, guys, okay, in the hub, whenever the PCA or PCB, okay, if they want to communicate with each other, what it hub does mean it broadcasts every time. Correct. It broadcasts every time. If any one of the PCs, say example, this is my X PC, this is my Y PC. If they want to communicate with each other, so they does the broadcasting again. Means what had happened here, the network performance will come down. The network will slow down. Okay, so whereas the switch is a very intelligent device than hub, and even it is a faster device. So what it does means it maintains your MAC table. So in MAC table it contains what? Okay, your MAC address and your interface name. Correct.
Sure.
Yeah. So what happened if A want to communicate with B? Okay, it broadcasts first time which are the PC you are connected here, which are the only active ports. It broadcasts to all. Okay, then it will read the address of A. So example, this A PC MAC address is this AA.AA.AA. For the B, we can write, say example, just I'm giving one example, guys, just to make you understand. Okay, same thing like C. So it will make an entry in the MAC table. And with the interface example, Fortinet 0/1. Okay, B also it will make an entry whenever the broadcast happen, communication happen, it will learn from Fortinet 0/2. Okay, CC, PCC, like Fortinet 0/3. It will make an entry, guys. Okay, so what happened? The next time if you want to if A want to communicate, if B want to communicate with A, so before broadcasting to all, first it will check the MAC table whether this guy is available in my MAC table. Yes, it's available. It means directly it will send. Okay, the network performance will be fast here. Network will be fast. This is the main advantage, guys. I hope it's clear, right, guys?
Yes.
Understood? All of you?
Yes.
Any questions?
Sir, currently we don't use hubs.
Huh?
According to implementing technology, we don't use hubs.
Oh, no, we are not using hub now. Nowadays, no hubs. We are not using any hub now. Okay, hub is gone now. Nobody is using the hub now. So all hub has been replaced to switch now. Only nowadays we are using switch now. So even right now we are dealing with your layer 2, right? Even layer 3 switches also available now, which is available in the Cisco packet tracer. We'll also do that lab. This this lab also will do. That layer 3 switches is your multi-layer switch. That is a multi-layer switch. I hope it's clear, guys, all of you. Okay, so let me close this. Okay, let's. Just I want to jump here. So switch features. What are the features for the switch, guys? So this is few basic features. Means you can see. So it supports your unknown unicast, broadcast, and multicast. It supports these two. So you have to remember, guys, this one. Okay, I think you know, right? What is a multicast, broadcast, all of you? We can see same example what I explained just now. So his same thing he's talking about. Right now we can see your MAC table. So right now the MAC table is empty, right? We can see the MAC table is empty. So right now the initial MAC table address is empty now. So let's say, so what happened? We can see the station A. Station A sent the frame to the station C. So what it does, guys, here? So these guys send the frames to the station C. What happened? So every guy is sending, not only for C, mean it will broadcast for all. Correct. Is going to do the broadcast for all. Okay, so the MAC address station A with the port number 0 by learning the source MAC address. So as we can see, so this guy, okay, he has learned the port number with this this MAC address. This MAC address belongs to the station A. Okay, the frame from the station A for the station is flooded out to all the port except the port itself. Okay, for unknown unicast port. So what it does means, apart from this port, it broadcasts to all, this guy and this guy. Means it will broadcast to for C, D, and B as well. So next what happened? So here, so we can see the station D send the frame to station C. Now this guy, station D want to send to your station C. Now what happens? So this guy also send the message. It will make an entry the MAC table. The port number is E3 with this MAC address. So again it will broadcast to all. So here what happens here? So the frames from the D to the station A flooded all the port by except the port 3. That is a unicast, unknown unicast are flooded. This is the job of your this thing. So now what happened next now? So here what we can see. So again, the station A want to communicate with the station C now. This guy want to communicate with station C. So what happened here? So this guy, destination is known. Frame is not flooded this time because, you know, before flooding, before forwarding the frames, it will check the MAC address table. Whether this guy is available in my MAC table. Yes, it is available in my Ethernet interface too with this MAC address. So directly it will forward to this guy. So it will not do the broadcasting. Okay, this is the basic concept of the switch. Same thing here. So here what happens, station A send the broadcast to our multicast frame. So broadcast multicast frame flooded all the ports, okay, other than originating ports. It floods, station D sends. Okay, your PCB broadcast or multicast. It will send to all to read. This is how, that's the reason the switch is very intelligent device. Understood, guys? Same thing is talking about. What are the things I talk? See, when the frame arrives to the switch, okay, Okay, destination hardware address. Hardware address means you should understand, guys. So he's talking about the MAC address. Okay, don't get confused, guys. Okay, so don't get confused, like hardware address means it is different. Okay, so if the destination hardware address is known in the list address, the frame send out all the correct exit interface, because it will learn, guys. As simple as this, guys. Let me explain you one example. Suppose right now when we started this training, because I don't know your names, right? So I know a few names. So for to prepare the MAC address with the with your address, with your name and your country name. So example, like she is there, Clara, she is from Malawi. Okay, Angie is she's also from Malawi. So Isaac, okay, he's from Tanzania, right? So initially, first day 1, day 2, I don't know each other now, because it takes for my brain to just prepare the MAC table. Same thing, switch does the same job. Okay, whenever the communication happens, it will read the MAC address, right? The same example is talking about here. If you see here, so right now initially the MAC address is empty. You can read switch 1 and switch 2. So both MAC addresses are empty here. When PC send the frames, so what happened here? The PC here sends what happened here? It will make an entry, right?
Yes.
You can see, right? You can make an entry here. Okay, from where it has learned. So from where it has learned, so it will make an entry here. So again, so PCC, again it will change here. Let's see. See here. So this guy also he has learned. So it has learned from port number. It has come from 323, and we can see on this port. Okay, so this is how your switch is going to work. And very interesting, guys. Switching is quite very interesting. So again, if you add one more PC here, okay, it will make an entry in the MAC table. We can see right here. It will make an entry in the MAC table. Again, it will come down. So here, what happens here? Here also it will make an entry. So it has learned from port number 23. Correct. It has learned from your port number 23. Same thing. If you connect one more PC here, it will learn from the port number 3. It will make an entry in the MAC table and forward to the switch 2. Okay, in the switch 2 also it will make an entry because it has learned for port number 23. It will make an entry in the port number 23. So as we have noticed here, and it will make an this MAC address will be enter in the both the MAC table. Right, this is a command that show MAC address. Command is there on your switch. Okay, we will do some basic lab, guys, today, and switch is quite very interesting, guys. So now, if you see here, what happened this time? So destination is now this guy want to communicate to this PC. Now this guy want to communicate with this. What happens here? So your destination is known, right? So this guy is available. So this switch, what it does means, so it will see the MAC table. Okay, destination is known. This guy MAC address is available in my port number 11. Okay, so in the port number 11 is available. That's the reason what it does means is directly it will send. It will not do the broadcasting. This is the advantage of the switch, guys. Means it doesn't consume much bandwidth. The same example, one more example he is explaining here. So we can see now destination 222. He want to communicate with this guy. So he want to communicate with this guy. So what happened? So here before sending MAC table, so in its MAC table, this guy is not available. So this guy is available in the port number 23. What it does mean, it will send to switch 2. In the switch 2, it has learned for 23. So this switch will indicate, so this MAC address is available on my port number 12. Port number 12 is available, directly to send. Okay. So let's talk about what is loop avoidance. Okay, so what is the loop avoidance? So how many are familiar with this thing, guys? What is loop avoidance? What is redundancy link? Any idea, guys? What is redundancy link? Redundancy links is nothing but a one links go down. Suppose example, this is my two switch. If I connect here like this, okay. So example, this switch, simultaneously two switches. Okay. So if one links go down, this will be active. This is called your alternate link or backup link or redundancy link. Understood, guys?
Sorry, can you repeat?
See, redundancy link is okay. It is nothing but a if one links go down, another will be come up. Say example, in this scenario, you have the two pieces connected with the two switches. Okay, if these links go down, still they can communicate in this way, and like this, he can reach. And this link will call it as your redundancy link. We'll call it as your redundancy link. Understood, guys?
Yeah.
Okay, what is loop avoidance? Any idea, guys? Loop avoidance? Any idea about loop avoidance? Okay, let's say example. So what is talking about? Okay, redundancy is a very good idea because they will prevent the complete network failure in the event one link goes down. So that's the reason it's talking about. If one links go down, okay, so it is alternate link will be up. Means he can communicate this way, right? So let's say example. So let me go for next slide. So network broadcasting loop. Okay, so when a match was send a broadcasting message. So here what happens here? So let me explain here with the next slide. Here they explain very simple way. See here, if what happened, if this server has sent any unicast message to this switch, so here, what happened? It will send to this guy, right? Again, it will send to this guy. Again, this guy will receive. So what happens here? What is the disadvantage here? Means the frame which has sent the broadcast message here, okay, here. So what happens here? It will duplicate, right? Same frame. Here also receiving and here also is receiving. Means multiple duplicate copy. So multiple duplicate copy you can see here, right?
Wow.
And right, so this will be big issue in the network. Okay, for that we are the solution is your spanning tree protocol. Okay, for solution is your spanning tree protocol. So what is spanning tree protocol? Okay, the basic idea for the spanning tree protocol. So let me explain. The example, so I have connected with the two switches like this. Okay, so if I connect switch like this,
Spanning tree is different and switching is too different, sir. How to involve this? Actually, spanning tree protocol, the system was different and switching is different topic, sir.
no, in the switching, we are going to learn the spanning tree protocol. The spanning tree protocol is what? The basic characteristic of the spanning tree protocol is what? Is going to block any one of the link by default to avoid the duplicate frame.
Okay.
right? Because when you're sending the frame, what happens? So again, it will send to all these ports, right? There's a lot of ports available
Yes.
on this switch. Right, a lot of ports are available here. So what happened means, because again it will send back. If these links go block means, okay, this frame will not come back to me again.
Yeah, if
Suppose-
the blocked, they will not come back.
Yeah, this is my switch 1 and this is my switch 2. Okay, when the frame has come to this side, okay, so it will not go back again. That is the job of your spanning tree protocol. Understood, right?
Yeah, okay, sir.
Yeah. So let's start the next session. So as you know that your redundancy in the network is extremely important, because redundancy is important, right? Because redundancy allows the network for the default tolerance. So basically the switch and bridge are subject to the broadcast star multicast frame transmitting MAC address and database installs. So here what is talking about, okay, therefore the redundancy required, carefully planned and monitoring your function of your property. It has to be designed your network. The spanning tree are used to switch the network to create the loop-free network. Remember, so this point is quite very important. The spanning tree protocol are used to switch the network to create the loop-free network. Remember, guys, this is quite very important. If you ask any what is the switching means, if you want, you can note it down.
Yeah.
So as I told you that, okay, the switching what it does means, so any one of these port is going to block, as I told you that. So prevent the loop-free redundancy network topology by placing certain ports into block states. When you connect the two switches like this, one port will be by default, it is going to block, because to avoid the loop, right? So keep on sending. Suppose these guys send any frames to this switch. Okay. So again, what happens? If there is no block bin, again he'll send back to him again. He will think it is a new frame. Is a new frame. Again, I have to do the broadcasting. Okay, which has this guy has sent the frame. Okay, again he'll receive it back. That's the reason your spanning tree is going to work by default. Okay, by default is going to work. It's going to block by default. So you need not do anything here. Okay, so as I told you that your spanning tree protocol residence in your data link layer. Spanning tree protocol works in your data link layer. Ethernet switch bridge implement in IEEE 802.1d. Spanning tree protocol used for the spanning tree algorithm to construct the loop-free network. So it uses algorithms like spanning tree algorithm. Okay, so it uses a spanning tree algorithm to construct the loop-free network. Okay, so what is this, guys? So this is quite very important, guys, to understand. So spanning tree port states. Okay, if any one of the link is down, say example, these are the two switches has been connected. So as you know, the spanning tree is going to block any one of the link, right? This is the job of your spanning tree. Now what happened? Okay. If these links go down, if one of these ports, say example, this port is down, what happened? If there is a no message, because this is my switch 1 and this is my switch 2. So every 2 seconds, okay, it will exchange your BPDU message. So bridge protocol data unit. Okay, what is BPDU means? Bridge protocol data unit. They'll exchange it. What it contain? BPDU. It contain your bridge priority and MAC plus MAC. BPDU, bridge protocol data unit. Every 2 seconds they will exchange. They keep on exchanging. If there's a, what is the job of BPDU means, it will check whether my neighbor switches is
What is BPDU, sir? Bridge protocol?
Bridge protocol data unit.
Yeah, okay.
Bridge protocol data unit. So every 2 seconds, it keep on exchanging their information to keep alive, whether my neighbor switch is alive or not. This BPDU. If your BPDU is not getting any reply, what happens means is going to block. The loss of the BPDU detected. So maximum age is 20 seconds. It wait for your 20 seconds. If 20 seconds we're not getting reply means this port will be blocked. So again, it will become here. This has to be come up, right? What happened here? It takes another 15 seconds for listening. Okay. So next thing will become learning. For learning, it will take another 15 seconds. Okay. Then it will become your forwarding. So totally how many? It will become the 50 seconds to come up the another port, another link. To become your red color to green color. These are the process. It takes 20 seconds, 15 seconds, and 15 seconds. Block, okay, loss of the BPDU. Okay, if you're not getting any BPDU reply, okay, say example, BPDU is nothing but a hello message, guys. So if I ask like, hello, Andrew, how are you? If you're not reply to me, what I'm going to do, maybe I think you are not listening, you just mute your headphone. Maybe you're not communicating, just maybe I think you're sleeping. I know you're not sleeping. Okay. Then what I'm going to do, so I'm going to block that port. I'm going to on the another port that is called alternate port. The red color to your amber color. Then it will become the green color. These are all the your spanning tree port states. Remember, guys, this is quite very important. Okay, so now discuss like what the first decision switch is the network weight. What is talking about? When the switch is turned on, spanning tree algorithm are used. Remember, guys, by default, all your Cisco Catalyst switches is going to run STP. By STP, by default, is going to work. That is spanning tree protocol. So, but if you take the two switches has been connected like this, okay. As you know, BPD message, okay, in the root bridge, used to identify the root bridge. So here is talking about the root bridge. So what is the root bridge, guys? Pawan, can you tell me?
Yes, sir.
What is the root bridge?
Next. The decisions that also.
So I will tell you guys, okay, root bridge is nothing but a team leader. Okay, so as I told you that for all the Cisco switches, okay, the default priority will be your 32,768 switches they have mentioned here. Okay, bridge ID consists of all the bridge priority by default is 32,768 and switch based on the MAC address. When the first switch stand up, it assumed it is a root switch and send the BPDU. This BPDU contain your bridge ID. Bridge ID is nothing but your this ID. So what happened? Both bridge ID are same, right? 32,768. If both the switch ID are same, then it look for your MAC address. Bridge ID plus your MAC address. Right. So all the bridge decide the bridge ID with the smallest bridge ID value became your root bridge, which has become the smallest value. That guy will become your root bridge. Root bridge, it is nothing but your team leader, head.
Okay.
Okay. Okay, even we can change one more point he has mentioned here. Okay, your network administrator may want to influence decision by setting up the switch priority to the smaller value by giving 4096. So actually default for the all the switches is 32,768. Fine, 32,768. You can reduce this value. Okay, then that switch will become your root bridge, guys. We can change as per your requirement. So here is talking about, guys, BPDU bridge protocol data unit. They'll exchange the information to use the selection of the root bridge. Bridge ID, what is this? Bridge ID, how spanning to keep track all the switches. Okay, it contains your 32,000 by default for all the Cisco switches based on the MAC. If all the 32 or all Cisco switches are same, okay, then he'll look for your MAC address. The root bridge, the bridge, that lowest bridge ID became the root bridge in the network. Remember, the lowest root bridge ID, that guy will become your root bridge. Non-root bridge is one. So these are all the bridge that are not the root bridge. These are not your root bridge. Root port. So what is the root port? Is always linked directly connected to the root port, or short part to the root port. Remember, so root port is one. This port is always directly connected to the root bridge. That is team leader bridge. Okay. Next thing is, if then one link connected to the root bridge, then the port cost is determined, checked by the bandwidth of the each port. Remember that. Okay. Then it will check for the your based on your MAC.
Okay.
Okay. Someone has messaged me. They have some emergency work. I think, who is that, Andrew or what?
No, not Andrew.
Okay, someone there's leaving the
No,
meeting.
Isaac, one emergency. I need to resolve it as soon as possible. We'll be back.
Yeah. So he just
Okay.
messaged me. Okay. So now he's talking about what he's talking about. So designated port is one which has determined the which has got the highest lowest cost. Okay, designated port will mark as a forwarding port. Okay, what happens? So let me explain this one. What is this? So this is the two switches which has been connected here. So example, this is my root bridge and this is my non-root bridge. Okay, this is the root bridge. So port which is connected directly, it will become your designated port. This is called your DP, designated port. Okay, and this will become your non-designated port. Okay, the forwarding port is one which is which link is active. So example, this is your forwarding port, your port. And one of the port will be blocked. So example, this port will be in the block state. This will be in your block state. So when you do the lab, guys, then we can understand. So now you tell me, guys, who is the root bridge here? Who is the root bridge here? Switch X or switch Y? BPD content what? Protocol, bridge protocol data in your default, send every 2 seconds. Bridge ID, okay, it equals bridge with the lowest bridge ID. What it contains? Bridge ID, bridge priority, and the MAC. I told you, right? In this example, which switch has got the lowest bridge ID? Now, who will become the root bridge guys here?
Switch
X.
switch X, sir.
How? Why? How?
800. Because MAC address is low.
Yes, because this is the lowest thing, guys. This guy will become your root bridge. Same thing is talking about. So there are some condition, guys. So you should remember this. Okay, one root bridge per network. In one network, you must have one root bridge, guys. This is quite very important to remember. Okay, you must have one root bridge for one network. So one root port per one non-root bridge. And one designated port per segment. One segment, you must have one designated port. Okay. So next thing is, so configuration, very simple, guys. We'll jump for the lab now. So in another few minutes, we're going to jump for the lab now. And this thing, guys, we should remember the cost, guys. This is the, you should memorize, guys. Selection of the root port. How you select, guys? You know, the link speed, 10 gig, 1 gig, 100 and 1000 Mbps. Okay. So this is the revised one, and this is the old one. The 10 gig speed, the cost is 2. 1 gig speed, the cost is 4. The 100, the cost will be your 90. Okay, and 10 Mbps, the cost is 100. Okay, which is the best? 2, right? Lowest cost.
Yeah.
Okay, the lowest cost is the best. Means this link is quite very fast, is very good. The same thing is talking about switch method. So let's jump for these slides. Guys, please remember switch method, guys. Switch method like cut through, forward switch, and fragment free switches, guys. So what it does, guys, here in cut through, frame is forwarded to the switch before it entire frame is received. So at a minimum, frame designated switch must be read before the frame can be forwarded. So this mode decrease the latency of your transmission, but also reduce the error detection. Okay, cut through. So whereas your frame fragment free, the modified cut through, okay, is filter out the collision frame before forwarding. So collision frame also majority the packet error. Fragment free mode switch will check the first 64 bytes of the frame. So it will check. So most are I think so before it will check. I think you might know carry sense multiple access collision detect, CCNA and CD. I think I told you right. Carry sense multiple access collision detect. So in the scenario is going to detect the error if it is in case if any error in the frame. But it will not do the modification, guys. Remember, it doesn't do any modification. Store and forward, entire frame is received before forwarding take place. Filtering are applied before forwarding to the, before it get forward. So first it will store, okay, before forwarding. What it does means, okay, it's applied before forwarding. Most reliable and almost every latency, especially when the frame is large. So this is the mostly nowadays we are using, guys. So most nowadays organizations we are using store and forward because so that it will be check your frames every time before forwarding your frames. Understood, guys? The configuration of the switch, guys. So we'll jump for the lab, guys. Okay, let me show you the configurations. I think it's same configuration. What are the things we did here, there? Okay. So example, this is my switch. We can do this all configuration line VTY. We can do your telnet in the switch as well. We can do this. We'll do the lab, this all this example, guys. The configuration quite very simple, guys. We can create the VLAN. Okay, what is the VLAN, guys? What is the use of VLAN? The purpose of the VLAN is, okay, in physical device, okay, imagine this is my switch. Okay, so these are all the ports. Okay, so I think right, guys. So I can able to connect some PCs here, right? So I can able to connect my some PCs here. So in the physical device, guys, I can divide this network and divide this into virtual VLAN. We'll call it as your VLANs. Dividing the physical switch into your logical VLANs. That is called, we'll call it as your virtual VLAN. Okay. So example, this is my VLAN 10, and this is my VLAN 20, and this is my VLAN 30. So example, this, if I give the IP address, say 1.2, 1.3, okay, 1.4 and 1.5, 1.6 and 1.7. So after creating this VLAN, can they communicate with each other, guys? Or if I connect this PC, I think without any configurations, I think they can communicate with each other, right? So, right.
Yes,
When we create the VLAN, okay, they will not communicate, right? For the solution is nothing but your inter VLAN routing, which we are doing the lab today. Okay, this is all, because that is the VLAN. So VLAN is nothing but your in the physical switch. We are going to divide the logically. Okay, because of the security reasons, we can divide. This is a very good advantage which is available here. Right, guys? Okay, so let's see how to configure this. We can see the VLAN 1. We can give the IP address for the VLANs, not for the interface. So he's talking about the layer 3 switch. Remember, the IP addressing concept is come under your layer 3, right? Got it. So there's a reason like no shut and exit and IP default gateway. So we can give the default gateway address also. So let's jump for the lab, guys. Can you jump for the lab, or we'll take small break now? So he is talking about VLAN, how to create the VLAN. Creating the VLAN is very simple. So example, this diagram, we can see, right? This is my first floor, second floor, and third floor. So each departments, so we have put one switches. Okay, so we have created how many VLANs? We have created 3 VLANs. Segment, flexible, security. Right. So this is how they are connected. So this is my sales team, HR team, and some engineering team. You can create like this. And some of the basic commands. So I think you should do from your side, like say R, DSCP, snooping. These are the commands, basic commands. We'll do these commands, no problem. You want break? Or shall I continue for the lab?
continue, sir.
Sir, send this PPT.
Sure, no, I'll send you, no problem. Just remember, after completing the session, I'll send you this PPT. Okay, see what is talking about. So logical definition defining of the interesting that limited of the broadcast. So okay, LAN created on the software on the switch. All the devices in the VLAN member of the same broadcast domain receive all the broadcast. So by default, filter on the ports. Okay, so what he's talking about, guys? He's talking about the VLANs. So what is a VLAN? Okay, in the physical switch where we are dividing into logical, there is called a VLANs. Okay, for the security reason. So what are the security reason he's talking about? So if you see the security reason, okay, tackled by connecting the hub switch together. The arrangement is ineffective because anyone cannot connecting physical network could be access to the network resource located. So it means we can divide logically as per your requirement. We can design your network. Okay, you can connect to, we can divide your departments. Okay, you can also do some security, basic level of security. That's what he's talking about. So how VLANs simplified? So what is talking about? So if you need to break the broadcast domain, we need to connect to the router. By using the VLANs, okay, so we can divide broadcast domain into layer 2. Okay, so we can divide this. Got it? So we can divide into your broadcast domain. A group of user need to be high security can be put into the VLAN so that no user can outside VLAN can communicate with them. Same thing, right? Yesterday just I explained. When you divide your network means divide your network by creating the VLANs. Okay, other VLANs cannot communicate to your another VLAN, even though it is connected to the same device, same switch. A logical group of user functions, but VLANs can be considered independently from other physical location, and they work as independently. It is going to work as independently. Okay, so here is talking about creating the VLANs. So we can see here. So VLAN based on the ports is known as your static VLAN. So what is talking about? Okay, the VLAN as in based on your hardware address into your database called a dynamic VLAN. So VLAN member, we have the two types, right? The first thing is your static VLAN and your dynamic VLAN. So what is static VLAN, guys? Any idea? Means manually we are creating. Okay, dynamic, it is nothing but it dynamically we are giving that. So that we can do by lab, that is your DTP. Okay, DTP also I not mentioned in your this thing. I will do that, no problem. That is dynamic trunking protocol. So dynamic trunking protocol. DTP, guys. Virtual trunking protocol or DTP. We'll do this lab. Okay, so what is trunking? What is trunking? So trunking is nothing but it will carry a multiple VLAN traffic in the single pipe. Remember, guys, it will carry your multiple VLAN traffic. So VLAN 5, 10, and 20. Okay, so where it does means this is my static VLAN and this is my dynamic VLAN. So maybe you're running VLAN, some different VLAN, like maybe VLAN 5, 6, 7, 8. So here like 11, 12, and 13. Okay, maybe you're running a lot of VLANs here. Correct. So what happens? So this trunk, if you make the trunk link, what happens? So it will carry this all VLAN traffic in the single pipe. That is the job of your trunking. Any question, guys? Understood what is trunking? So static VLAN is a more secure, as it's talking about. So is a more secure, easy to set up and monitor. So well known in the network where the movement of your network user is controlled. This is it has been well controlled, guys. This one is well controlled. So whereas your dynamic VLAN, so in dynamic VLAN, determine the nodes by assigning automatically. That is your dynamic VLAN. It is dynamic trunking protocol. That lab also will do it. Using intelligent management software, so we can base on the VLAN assign the hardware MAC address. So we can assign automatically, we can create the VLANs. Okay, so because this is very helpful when we have a lot of big organizations where you have a lot of PCs has been connected. So there is required. Okay, when we want to create the VLANs. Okay, so dynamic VLAN need to be VLAN management policy server VPN, VMPS. So you must have the VLAN management policy server to manage this, because it is purely automatic. Now come to the configuration. So configuration, rather than doing the configuration, we'll do directly lab for this. And these are the topic, guys, which we are going to discuss in coming these things, guys. Okay, so right now we have opened already, guys. So do you want break, guys, for 15 minutes?
Yes.
Okay, after 15 minutes, we'll do the full lab. Okay, so let me write it down the break time here. Is it okay, guys?
I wanted to continue, inshallah ta'ala, in tawassul ila Allah, dua, how to get closer to Allah subhanahu wa ta'ala in our du'as. And I hope, inshallah ta'ala, now, by the end of the month, really we'll have some of the adab, some of the mannerisms in the dua. And the one that I'm going to talk about tonight is one of the most potent ways to have your dua increased in quality and beauty, but it's also one of the most dangerous concepts if not applied appropriately. And that is the concept of al-inkisar, to be broken in front of Allah subhanahu wa ta'ala, to idhar al-faqr, to show your poverty, to show your vulnerability, and to speak of it in the capacity of your dua. It's actually pretty dangerous if you do it wrong, but it is very powerful if you do it right. So I want to give you an analogy actually that I was thinking about, subhanAllah, as we went into ayat sajda in Surah Al-Furqan. We have the verse of sajda, and then وَالَّذِينَ يَبِيتُونَ لِرَبِّهِمْ سُجَّدًا وَقِيَامًا. Allah subhanahu wa ta'ala emphasizing people that spend their nights in prostration and sujood, and Allah subhanahu wa ta'ala condemning those that don't make sujood to Ar-Rahman. So I want to give you an example here. If your dua could be drawn out, what does a dua look like in sajda? You know, physically speaking, right? You have the image in your mind. When you physically humble yourself to Allah subhanahu wa ta'ala, your face is on the ground, and you're saying Subhana Rabbi al-A'la, right? What would your dua look like if it had a physical image to it? How do you make your dua like a sajda, right? And so we just talked about how to extol the names and attributes of Allah subhanahu wa ta'ala, right? Al-Asma' al-Sifat. And so you're glorifying Allah subhanahu wa ta'ala, and you want to humble yourself. You want to lower yourself to Allah subhanahu wa ta'ala. And we find this in many places. In the Quran in very beautiful ways. Completely desperate for going to send to me. I am completely in need of that, right? So extol.
Okay, guys, I'm back now. I hope all people are back there. Guys, are you there, all of you? Can I start the lab now?
I'm available.
Yeah. So I hope all people are joined now. Okay, let's see. So I'm going to do the very basic lab now. That is like how your spanning tree is going to work, how is your DR, BDR election process, then we'll create the VLANs. The 3 lab will do it right now. Fun guy? Okay. So what are the first thing is I should guess? Let's take switch guys. We know these are the list of switches available in the bottom of the screen. You can see right in the packet tracer. So right now, as per this thing, we can see. So these are the list of packet tracer where we can see. So let's right now, this is the multi-layer switches, guys. What we can see, this is a multi-layer switch. And this is your layer 2. So right now we deal with the only layer 2 now. So we will not use this layer 3 right now. So right now I'm going to use only these 2 switches. Okay, so let's connect it. So right now I will take manually. I'll connect 2 ports in the port 1 and 2. You notice, guys, so all links is in amber colors. So now it will become your green color. In that green color, 1 port will be blocked because of your spanning tree. You can see, right? Just open this. Okay, go to CLI. Same thing, how you are opening the router here, same thing here. Okay, show VLAN. Or say show spanning tree. Show spanning tree. See, we can see these 2 ports what we have used. It is 1 and 2. So both are designated port and both are into forwarding ports, and cost is 19. Okay, and this is your root bridge. Okay, as I told you that, we can see, right? So as I told you that previously, okay, the default priority is 32,768, and one is nothing but your system ID. The actually is your 32,768. Remember, guys. Okay, the priority is your 32,768 plus this ID. That's the reason it's showing 72,768. And remember, this is my root bridge. This switch is my root bridge. And both are into your forwarding state. Both ports are active with the cost of 90. Okay, so let me check with this switch now. Show spanning tree. So we can see, so this guy is not your root bridge. The cost is 19, the priority is this. Okay, and 1 port is blocked. I have notice here, 1 port is blocked. We can see right here. And 1 port is in forwarding state. And this is not a root bridge. And this is not a root bridge because 1 port is blocked. And this is only 1 port is your root port. Only 1 port we can see, this is your root port. Understood, guys? So now what happened? So what I'm going to do now? So I'll make one of the link down. Say example, this interface. I'll make it down. Okay. So I want to explain how it will become your spanning tree port states, which I explained, right? Listening, forwarding, blocking, listening, forwarding. Okay, so go to global configuration mode. Okay, interface Ccna 0/1. Okay, then you do shut down. Now you check show spanning tree, but still it is a root bridge, right? Now these two ports will become active now. Show span. See, it is listening here. Can you see? Can you see, guys? So here it is listening. Okay, now it has become forwarding. Can you see? Now it has become the forwarding state. You can see, right? Only these two links are up now. As per this sync topology, guys, we can see. So these two links are up. This is blocked because manually we did block. Okay, so how many seconds it takes? So it takes almost for blocking. How much time is take, guys? 20 seconds. If BPDU lost, it takes 20 seconds. And for listening, it takes 15 seconds. Okay, and learning, it takes another 15 seconds. So totally, it will take 50 seconds to come up this link. Okay, if you talk about the real time in the production network, guys, so this 50 seconds is not accepted. That there is a solution they have come up with, that is your, okay, a PVST. Okay, or okay, rapid spanning tree protocol, RSTP. This is a problem with the spanning tree protocol. It takes long time, right? 50 seconds means 50 seconds means almost all 1 minute, right? 1 minute, there is no internet, no communication. What about the sectors like your banking? If 1 minute there is no internet means loss to the bank, right? What about like stock exchange? And for them also lost, right? If the 1 minute the link block is, that is here about spanning tree. It takes 50 seconds to come up with other link if any one of the link is go down. Guys, you are following me, right? Any questions? Guys, are you there?
Yeah, following.
You're following, right? Yeah. So let's make it down up back to again now. So I'll go to global configuration mode. Okay, interface Ccna 0/1. I say no shutdown. So let's see if you type show spanning tree. See, it's listening, right? Can you see? Listening. Okay, now learning. Can you see? Now it is become the learning now. So after a few seconds, it will become forwarding. We can see there. Yes, you can see, right? Both are now into forwarding state. But it's taking long time, right? Which is not accepted, guys. Okay, it's taking 50 minutes. Of course, we can do the port security. Okay, that I will show you that. Understood, guys? What I explained, DR and BDR. So what if you want to make this guy as a designated router? Right now, this is my DR, right? So as per this thing, okay, who is the DR here? This guy is the root bridge now. He is the root bridge. And this is your non-root bridge. So what if you are the engineer now, network engineers? I want to make this as a root bridge. How we can do that, guys? Just simple as this, guys. So let's say, okay, I'll make first go to global configuration mode. I say this is my switch 1. Okay. Right now, this guy is the root bridge. This guy is the root bridge. So what we can do, go to this switch. This is my switch 2, which I want to make. This is my root bridge. Okay, spanning tree, give the question mark. Okay, guys. See, remember, before I could explain, show VLAN. Okay, show VLAN brief. So we can see here, these are the list of VLANs where we can see. So by default, guys, please remember this. I want to emphasize some important points here. By default, these all VLAN available in VLAN 1. And this VLAN also will call it as your native VLAN. So this VLAN you cannot delete. In this VLAN 1, okay, these all ports are available. These all ports are available in this your VLAN. Okay, this level like where we can do it for your active VLAN, all of that we should discuss later, not now. Okay, so now how do I do that? Right now, this is my switch. I will go to global configuration mode. Okay, spanning tree. Okay, VLAN 1, because you know all the ports are available in that VLAN. I want to make this switch as my root bridge. Okay, give the question mark. So we can see here, we can set your this thing priority, or we can select the root also. The two way we can give the command. Let's say I'll go first for the priority. If you give the this one priority, so it will show you a priority. We can give up to 0 to 61,440,440. Bridge priority incremental by 4096. Okay, what is this by 4096? Okay. Okay, this is a 4096. I can give this value as well. No problem. Now, the moment I given, we can see, right, it doing some changes. Right. Now, this guy will become the root bridge. Say, let's say, and show spanning tree. You can see, right, this guy has become the root bridge now. Is listening state still now. It will come active. Now it is learning. You can see both are into forwarding state. This guy became the root bridge. Understood, guys? Understood. Pawan, Clara, Asma,
Yes. Yes, sir.
Andrew, Isaac, Sahil Gani, you understood? Someone has joined with Zoom user. Who is that?
Sorry, it's me, sir. I didn't change my name. Let me rename my name. Salmin.
Okay. I got confused. Who is Zoom user? I thought mine.
Sorry.
Okay. Salman, you're from which country, man?
Tanzania.
Tanzania. Okay. And you and Isaac belongs to Tanzania.
Yes.
Okay. Understood, right? All of you? Okay. So let's do the right now. Who is the root bridge, guys, now? As per our this thing. This switch is your root bridge. This is a root bridge, right? And this is your non-root bridge. So now what I'm trying to explain here. So how do I create the VLANs here? Anybody idea, guys, how to create the VLAN? So I'll go to global configuration mode. Okay, interface VLAN, say VLAN 10. Okay, name, sorry. Not interface, just VLAN. So VLAN 10. Name, I will say example sales team. Okay, then I will create VLAN 20 and name I will give say example security team. So right now I'll create only 2 VLANs. Okay, so now what I'm going to do, just me connect some PCs here. Just I'll connect 4 PCs with auto. Let it connect automatically. So what I'm going to do, guys, so let me assign IP address manually. So example, like I will give like 192.168, say 1.1. And gateway is same. This is say example 1.2. This is 1.3 and gateway is same. Just I'm assigning the IP address, guys. I'm not doing anything. Just I'm assigning the IP address. This is 4. So can they communicate with each other, guys? Can we check? Yes, right? So each one, they have got the communication now. Correct? Understood, guys? Each one, they have got the communication now.
Yes, sir.
So as you know that, okay, see, show MAC table. You can see Dynamic, he has learned the MAC table. Have noticed, guys? So these are the MAC address for the VLAN which we have connected. So port number 1 and 2. So 1 and 2 is connected for to whom? Understand, guys? So these port numbers, port number 1 and 2 is connected to your switch 1. Okay, and this one 6435. This is connected for your 4 PCs. Understood, guys? So these are 4 PCs has been connected. The MAC address of this all PC we can see, right? So these are the MAC address of the PCs he has learned. And it has learned dynamically, he has learned the MAC address. Okay, they have the perfect communication now. Okay, they have the communication to each other, this guy to this guy. Okay, so now what I'm trying to explain here, so let me open that. So as we know that we have created the 2 VLANs, right? Show VLAN. We can see, right? We have created 2 VLANs here. Correct. We have created 2 VLANs. Okay. So now we can see these 2 VLANs, it doesn't contain any ports. Okay. So how do I assign? So let's say this is my faucet Ethernet 3 and 4, 3 and 4, and 5 and 6. So what I'm going to do now, let me put it the color. And these 2 belongs to my VLAN 10 and this PCR belongs to my VLAN 20. So if you want, we can write it down for better understanding. This is my VLAN 10 and this is my VLAN 20. So what I'm going to do now, I'm going to assign this port number, which what is the 3 and 4? 3 and 4. These two ports, first understand this. So these two ports I'm going to assign for my VLAN 10. 5 and 6 I'm going to assign for my VLAN 20. Understood, guys? This is what I'm trying to explain you guys. How do I do that? Guys, you are understanding, right?
Yes.
Tara, Andrew,
Yes.
Sahil, Gani, want to following, right? So let's do that. So how I can do that? It's very simple command. So go to global configuration mode. Okay. Interface range. Okay. I want to take 3 and 4 ports. Fast Ethernet 0/3 and 4. I will take these two ports. These two ports are access ports, switch port mode access. You have to tell them these ports are access ports, switch port access to VLAN 10. Means we are assigning these two ports to these two ports connected to PC, right? Okay, then exit. Same thing, the other also. Other one is 5 and 6. Okay, here also you are the switch port mode access, switch port access for the VLAN 20. That's it. If you type show VLAN, we can see this all port has been assigned. So now we cannot see here these ports. Understood, guys? So can they communicate now?
No.
No. Why? For inside VLAN, they will communicate. Inside the VLANs, so they will communicate. For other VLAN, it will not communicate, even though it is connected to the same switch. Understood, guys? So previously it was getting communication to each other, right? Now it is not. Any questions, guys, here? No questions? Asma, are you there? Pawan, Asma, any questions? Can I go ahead? Next lab?
Yes, sir.
Okay. So how do I make them communicate, guys? How do I make them communicate with each other? So what I should do, guys? Any idea? So let's say, example, this switch, I'll delete it. I don't want to use this switch. So how do I make them communicate with each other? Is it so let's say I will take one more switch here. So here I will connect same like 4 PCs. So like manually I will connect it, the connections. And this lab is nothing but your inter-VLAN routing, guys. So what I'm trying to do now, so let's do that. So let's say and this is belongs to my VLAN 10 and this guy belongs to my VLAN 20. Same like what we did in other part, same thing here also. And this is my VLAN 10. Clara, you're following what I'm trying to explain here. Just very basic lab. I'm not explaining the very high end this thing. You can see, right? One of this thing. Right now, this guy is your root bridge. You can see, right? Show spanning tree. It will show you that if you type this one, we can see this guy is the root bridge. Correct, guys. This all for all the VLANs, this switch is your root bridge. Right? So same like here also, you just create the VLANs here in this switch as well. So let's say I'll create this is my switch 2 and VLAN 10 name. I think I have given sales team. Okay, and VLAN 20 name I'll give security team, right? Do show VLAN. So right now what we did, just we have created the VLAN. That's it, nothing else we did. Okay, so right now we have created same VLANs. So what I'm going to assign, so we are going to assign the ports, which are the, it has been linked. This is 1 and 2, and this is, I think, 3 and 4. So be carefully while assigning the port number, guys. Okay, interface range for Ccna 0/1 and 2. Okay, these are the switch port mode access. Switch port access for the VLAN time. Okay, so now what I'm going to do, so exit, same, repeat the same command, that is interface range, I think 3 and 4, I'm sure. Yeah, 3 and 4. So 3 and 4, so you people are switch port mode access, you are the access ports, switch port access for the VLAN 20. That's it. If you type show VLAN, so we can see these ports we have assigned. So let's configure the IP address for these guys. As you know that we have not yet configured the IP address for this. So 192.168 example, this is 1.6. So 192.168, 1.1 is a gateway. 1.6, and this is 1.7. And this guy is 1.8. And this guy is 1.9. Okay, now tell me, guys, can they communicate with each other now?
Yes, they will.
Well, can you check now? Say example, VLAN 10 and 10. No. Fail. Check once again. Fail. But internally, they will communicate. And internally, they will communicate. So internally, they don't have any problem to communicate. They do communicate with internally. But this VLAN to this VLAN, they will not communicate. So what we should do now? What we should do now? This is my root bridge. And this is my non-root bridge. Because one port is blocked, right? Spanning tree, one port is going to block here. Right? Okay. So what we should do, guys, just we have to make the trunk link for these two interfaces. So what I'm going to explain here. So these two ports, okay, these two ports, what is available here. So we have to make the trunk link. Just we have to make your trunk link. So what is trunk link?
The link that will connect to different VLANs or several VLANs.
Sorry, can you come again?
It is a link that will carry several VLANs.
Yes, yes. Fantastic. Very good. Okay. So what I'm going to do, guys, so just I'll enter into the first root bridge. Okay, I'll select the two interface. I'll make it as a trunk link. Okay, so I think we should change the host name. This is my switch 1. Okay, interface range. What is that? Fast Ethernet. Check which are the interfaces it has been connected. I think this is which interface? One is connected to 5, and one more interface is 6, I think. Correct. Not 6. I think 1 and 2. And here 5 and 6. Correct. Interface range fast Ethernet 0/1 and 2. Okay. Switch port mode trunk. We have to make this as a trunk link. Okay. Switch port trunk, give the question mark. Okay. So you have to allow all the VLANs. Okay. Allow VLAN. Allow VLAN. We give the question mark all. We have the option like word add, accept, non, remove. Okay. I am going to allow all. Which are the VLANs available here? So I am going to allow them. Then show interface trunk. This is the command to check whether it is a trunk. We have made it, right? We have made it. It is a trunk link now. Right. So what about this here? Show interface trunk. Okay, this guy has become the auto now. This file has become a trunk link now. So can they ping now? This to this. So can they ping this blue to this blue? Yes. And this blue to this blue, yes. And this blue to this blue. Success, right? You understood what I did, guys, here? So what I did is, okay, I have made this as a trunk link. That's it, nothing else I did. So what I did, okay, this link, okay, I made it to trunk. Where these two VLANs topic is going to cross and communicate. Okay.
Before we proceed.
Yeah. Yeah, Andrew. Yeah, Andrew. Go ahead.
I've just noted that from the non-root bridge, now the link is blue. should it mean that after trunking, you should change to that blue? But at first, it was amber.
So it takes time to come up to become the green color to amber color to green color. It takes time depending upon your switch speed. Because we made some changes, right? We made some changes. Say example, I think this is the switch so these two links we have made it as a trunk. So this link became the amber color, right? So now this is up now. Both the links are up.
Yeah, my question was,
Yeah.
on the non-routed bridge, we had that port that was closed.
In the root
That was
bridge?
in interface FA05.
Okay.
It was blocked
Mm-hmm.
because
No, what is your question now? So what are you trying to ask me? Andrew, are you there?
yes.
No, what is your question?
My question is, when we're using a trunk, all ports will show up in green form. No port should be in amber form. Is it like that, or maybe we should have another?
Yes. All ports should be up. All ports should be up in the trunk link. If you made the trunk link, it will come down. First, it will become amber color. Then it will read the what things you made the changes, what you have configured.
Noted.
Got it. If you do some configuration, so again it will come down, again it will come up. It will read the new changes. Just to what we did, we configured your trunk link, right? So as we can see now, each colors, I think they can able to communicate with each other. Say the blue people, they can communicate. Okay, and these light blue, they can communicate. No problem. This is called your inter-VLAN routing. Understood, guys?
Can you hear me?
Yes, Clara, tell me.
I was trying to ask. I don't know if it's similar to what I'm talking about. So my question would be: does it mean it's still working?
Your voice is so less, Clara. Can you be a little bit louder?
Can you hear? Is it better?
No.
Clara, you are very faint.
I think she's very far from her mic.
Hello?
Yeah, Clara, now it is a little bit better.
Okay. I was asking the same issue that Andrew is asking about on the Amber link. Does this mean the STP is still working even though both seem green?
Yeah, STP is working by default.
Okay.
It worked by default.
Okay.
Okay. So is it the same question you asked? Andrew also asked the same question.
All right.
Okay. So let me save this one.
Sir.
Yeah, Andrew.
My question came in the sense that we had that port blocked to avoid that rope, which said that from the non-routed, can you remove that?
Non-bridge.
From the non-bridge router, a non-bridge switch.
Non-root bridge.
Yes, non-root bridge.
On the root bridge,
you said that we have another port that be blocked to avoid the rope, but now that port is no longer there.
Yeah. Because we made a trunk link, right? For this, we can see two ports. 2 ports, we made it as a trunk link with the encapsulation 802.1q. We made the trunk link. We can see, suppose if you type show spanning tree, okay, we cannot see the only one port has been blocked. 2 ports. If you see, the 2 port is actually blocked in this interface. Port number 2. If you check in non-root bridge, show span, all ports into forwarding. So as per this, what happened now? So this guy has become the root bridge. Now this is not a root bridge now. Actually, this is the root bridge. Got it now? You can see, right? Root bridge. This is the root bridge now. Because all ports are into forwarding. Can you see? All ports are into forwarding state. You can see these all ports are into forwarding state. And this is your root bridge.
All right, noted, sir.
Got it? So now, if you check this router and this switch, so 1 port is blocked. 2. Okay, what if I want to make this as a root bridge now? How we have to do, guys? Who will tell this? I think I told you already this.
Yeah, you reduce that value. You assign a small value.
Yeah. So what we have to do? So go to global configuration mode, spanning tree. Okay. VLAN. Okay, so example spanning tree mode port fast for the VLAN 1. So it will give the priority. Okay. So we can give at this time I will give another way. Root. Okay, root. We can make as this as a primary or secondary. We can do this way also. We can give this one also priority. So priority, how much I can give? So priority I can give 4096. Okay, so let's say 4096. So now this guy should be become the root bridge now. Correct? Show spanning tree. See, one is getting blocked. Check, this is non-root bridge. This is the root bridge. Why? I want to make this as the non-root bridge as per this diagram. This guy has become still root bridge. Check this guy. This guy is wanted to blocking state. How I can do that, guys? Go to spanning tree for VLAN. For VLAN, which are the VLANs? For the VLAN 10, VLAN 20, VLAN 30, VLAN 10 and 20, right? Only 2 VLANs. Okay, and this in priority 4096. If you type now show span, now this guy became the root bridge, right? Can you see? Is listening now. Listening, it will come up. Is listening now. Learning now. Still is learning. But it has become already a root bridge. You can see, right? The priority has become reduced. 4116. Now this guy became forwarding state. All ports are into forwarding state. And this is your root bridge. Okay, for the VLAN 20, this is the root bridge. Okay, and whereas for the VLAN 10 also, so this guy is a root bridge. And check for this guy, you can see one port is blocked right here. So previously it was showing the root bridge, right? Can you type once again this command, show spanning tree? So this guy is no more root bridge. You can see, right? For the VLAN 1 is a no root bridge. For the VLAN 10, okay, there's not a no more root bridge. We can see one port is blocked. Understood, guys? Understood, Andrew, Clara,
Yeah.
Sahil Gani,
Yes.
Asma. Okay, so let me send you this file, guys, with the commands, right? Is it the commands is helpful for you guys? Which are the commands? I'm sending the 2 files, right?
Okay.
Is it helpful for you guys?
Yes, it is.
Okay. So this is inter-VLAN routing. Yeah. So let me send this file. I think you want the slide also, right? For this today's. Yeah. So I'll also share you the slide also there.
Yes, that would be very helpful.
Yeah. So slide also I'm sharing you. Yeah. So please check from your side whether you have received or not. Download it right away. The slide also I show you. These slides are very good. So we are preparing workbook, guys, for the CCNA. That is 200-301, right? For the CCNA exam. For the CCNA exam, so that is 200-301. We are preparing the workbook, or we'll also call the cookbook. Where it will help you to do all the labs. By seeing that, we can able to do your labs in the packet tracer. You can do that. So we're doing, maybe I think it takes time because, you know, we need to do some changes. We need to add topology with the commands. Everything will be there. Okay. If you have workbook with you, so no issues. So I'll share you once it is get ready. Okay. Anyhow, we are connected even. So one more thing, guys. So next week will be the last weeks of this training, CCNA training. Saturday and Sunday. I'll be completing this all switching part. Okay, still you can connect it with me. Anyhow, I'm available in the WhatsApp. My number is there with you. Okay, I think you have received, right, all the files?
Yes.
Okay, so can we jump for the next lab now? You understood? Andrew, Clara, Asma.
Yes, understood.
Okay. Because you people are also spending time with me. I'm also giving some time. So you should come up some result, right? So next lab we shall discuss about we are using like inter-VLAN routing with a separate interface and with a redundancy interface as well. So let's do that. Okay. How to create the VLAN, all of you understood, right? If you have any question, you can ask me, guys. Don't get hesitate to ask the questions. So let's take the next lab now. So let's say I'm using the two switches now. Okay. So after this, we'll go for the multi-layer switches as well, like advanced lab for the switching part. So do you know what is the difference between like access layer and trunk layer, guys? Access layer and trunk layer. Guys, are you there?
Yes, we are.
So what is the difference between access layer and trunk layer? So what is different, guys? What is different between access layer and trunk layer? So access layer it is nothing but a part of member of only for the VLAN. Carry the traffic for only one VLAN. Normally access are connected to the end user devices, guys. First remember. So as per this diagram, we can see, okay, let's say, so this link will call it as your access link. And this link will call it as your trunk link. Understood, guys? Yes. So usually access layer will be connected for your end user devices, guys. Remember. No. Correct? Okay. Always access layer. That's the reason when you do the command. So whenever you are doing these commands for switch Fortinet 0/1 and 2, so we are making as a access port, right? Switch port mode access. Right? And assigning for the VLAN. That indicate that we are making them as a trunk link. Yeah. Okay, same thing we are going to do because already we did this lab. So why I'm explaining again here is because, you know, this is quite very important, guys. to understand this trunk link. Okay. So now what I'm going to do now, so let's see, I will use one router here. So let me connect one router to this switch now. So as you can see, the router which is connected here, let's put it down this. Gigabyte 0/0 is connected for the 3 now. So now we can see these two switches. Right now I am using one PC. So I'll put this into the different VLANs. Say, let me put some colors for these guys. So this PC, I'll put it in different color. Okay, color selection. And this is in different VLAN. And this is into different VLAN. I don't want to take a lot of PC, guys. That's understandable. So, you know, if it is, can they communicate, guys? If it is a different network, the lab for this one is, guys, this is also, we'll call it as your inter VLAN routing. Say example, okay, so I'll put it my VLAN 10 and this is my VLAN 20. So this time what I'm going to do, okay, so VLAN routing method, guys, first understand, there are the 4 different methods we can do in VLAN, guys. Okay, so let me write it down. Okay, so VLAN routing methods. So first one we talk about VLAN routing table, VLAN routing with separate gateway. Separate gateway interface. And second one is your VLAN routing. So VLAN routing with router 8.2.1q trunking, which we did already. Second, we have done just now. We made the trunk link, right? And another that is nothing but a VLAN routing with layer 3 switch SVIs. SVI means switch virtual interface. Okay, and fourth one is, okay, that is a VLAN routing with layer 3 switch routed ports. We'll do it, this is optional, we'll do it. So right now, which lab we did just now? I think this second one we did. Understood, guys. So right now we are doing, we'll do this lab now, inter VLAN routing using the routers now. There are many methods, guys, depending upon your requirement, we can do that. Okay, so let's do that. Okay, I'll be using router on stick method also is there. Okay, there are many methods, guys. So let's say example, let me draw the diagram for this. Separate interface. What does it mean by separate interface? You can see, right, where is that? Yeah, first one. So what a separate interface means, say example, this is my router. So what I'm going to do, okay, this is my switch. Okay, so where we are going to connect some ports. For the ports, we are going to connect your end user devices. So here, how they will connect it? They will connect like this, guys. Say one of the ports, example, one of the ports are free here. So they will connect this way and they will connect this way. And say this is my fast Ethernet 0/1. This is fast Ethernet 0/2. So this is my router. This is one method of doing that. So example, this is my network is 1.100 and this is the 2.100. Different network. Okay. And another method is, okay. So another method which I am doing here, this one. So one physical interface I connected and one switch where we have created the VLAN 10 and VLAN 20. This is one more method. And other method is using SPI interface. So what we'll do, so we will take multi-layer switch here. So in multi-layer switch, what we are going to do, we are going to add your one more switch. Okay, in this switch, what we are going to do it, so we will connect like this. And here we'll connect some computers. And here we'll create separate VLAN. This is separate VLAN, this is separate VLAN. Say example, and this is my VLAN 10, this is VLAN 20, let's say black one, VLAN 10, and this is VLAN 20. And here what we are going to do, we are giving for the SPI interface, that is interface VLAN 10, we'll give the IP address 1.1 and for the VLAN 20 for the 2.0. And they'll all communicate if we have the routers. We are going to do this lab, all these lab guys. That's the reason I'm explaining you. So what is the first step we should do, guys, here? Guys, are you there, all of you? Let me check.
Yeah. Well, Viram.
Okay. Yes, Andrew, what we should do here first?
We should go into the route and
yeah. See here.
configure.
Yeah. So go to this
into the
router.
switch.
In this interface, we have to create the two sub interface. Okay, gigabyte 0/0/0/0.10. Okay, here I am going to give the IP address. This is 1.100 or 1.10/24. Gigabyte 0/0/20, that is 2.10/24. We can create sub interface. Okay, so let's do that. Yes, Andy, you're telling something? You have to go to the router and telling something.
My suggestion of the same as you have said.
Okay. So which lab you want me to do now? Right now we are supposed to do almost, I think, 4 labs, right? 4 labs are supposed to do now. Okay. Now tell me the first step, what I should do here. So what I should do first here for the VLAN sub interface. Right now, say example, I don't use this command. So let's delete this entire thing. Just to avoid confusion. It's very simple, this thing. So what I'm going to do as I return here. So one is gigabytes 0/0/.10 sub interface. These are as a 192.168 1.1. for my VLAN 10. Okay, same thing, gigabytes 0/0/0.20 for 192.168.2.1. This is for my VLAN 20. Okay, here I will create the two VLAN, VLAN 10, VLAN 20, and assign these ports. Okay, so let's do this. First jump for the router now. So interface gigabytes. Okay, so first we have to assign the IP address, guys, right? Okay, for this interface gigabyte 0/0/0. Okay, so no IP address. Okay, no shutdown. Okay, say. So what I'm going to do, interface gigabytes 0/0/0.10. Now I have entered into the sub interface. Can you see? Right. So now what I'm going to do, so just I have to assign the IP address for this interface. Okay, we can give no short and no IP address for the interface, but I have given only this, but no problem, it will work. Okay, now just I have entered into the sub interface. So now I think encapsulation work. So encapsulation dot 1Q 10 for the VLAN 10. Okay, then assign the IP address. So what is the IP address I should give? 192.168.1.10 255.255.255.0. That's it. Okay, so now come back. Then again interface gigabytes 0/0/0 dot. If you give a dot and give the question mark, okay, these are the number of sub interface we can create. Understood, guys?
Yes.
This number of sub interface we can create. Okay, here I will create 20. Okay, so here encapsulation dot 1Q for the 20. Okay, IP address 192.168. This is my 2.10. Okay, that is 1.10. This is 2.10, and give the subnet mask. Okay. So I say no shit, come up, no problem. So now switching routing is done. Now switch. In the switch, what we should configure? We have to create the two VLANs, right? VLAN 10 and 20. So VLAN 10 name I'll give sales. Okay, for the VLAN 20 name I will give HR. Okay, so just we have created the VLAN now. Do show VLAN. So right now we have just created the two VLAN. So I have created port number 1 and 2. Okay, let's assign for that. Okay, interface for Ccna 0/1 switch port mode access. Switch port access VLAN. Which VLAN, guys? VLAN 10, right?
Yes.
Okay, so then interface for Ccna 0/2 switch port mode access. Switch port access for the VLAN 20. We can see show VLANs. So now both the ports has been assigned. Okay, so what are after this, what we should do, guys? Is anything missing here? Can they communicate now?
No,
Why?
because you haven't created a trunk yet.
Yes. Who is that?
Shahil,
Very good, man. Very intelligent. I like it. Okay, so go to interface board. Okay, which port link we have to make trunk link? Which one, guys?
FCR3.
Yes, very good. 0/3. Oh, sorry. Okay. Switch port mode trunk.
Trunk.
Switch port trunk encapsulation is not going to work here. So for that, what we have to do, what we have to do, just allow, because it is a layer 3, layer 2 switch, because this command is applicable for layer 3, because it is old switch. Allow, okay, give the question mark, okay, VLAN. Okay, which are the VLAN? You want to allow all
All
VLAN. That's it. So show interface trunk. Yeah, so we can make it. Show VLANs. So can they communicate now, guys? Can we assign the IP address for these two? I think we are not yet assigned any IP address. So 192.168, this is my 2.1. 192.168, 1.1, 192.160. What is the gateway, guys? Here?
Wait. Oh, I thought the gateway is 1.1.
Mhm.
Because that's the IP we put on the router.
Yeah, so 1.10 I have given the gateway. Okay. So what should be the IP address for this guy? So 192.168, this is 2.1. So 192.168, this is 2.10. So I think they should communicate with each other, right? Oh, it's failed. Success. Understood, guys?
Yeah.
It has got the communication now. If you check the interface here on the router, show IP interface brief, we can see these all interfaces are up. We have created 2 sub interface. Right? We can see these 2 sub interfaces we have created. Okay, 10 and 20. We are given this all IP address.
Okay. Oh, okay then. Can you just correct the labels on the interfaces for the router?
Yes, correct. This is 10
Yeah.
and this is 2.10. Thank you, Clara, for correcting me. I'm also a human being. I do mistake, right? I'm not a computer, right? Even computer also do some mistakes sometimes. Okay. Okay, so I'll say this one. And this is same lab as inter-VLAN routing. Inter-VLAN routing lab 2. So I'll send you these 2 files, guys. Understood, right? How to create the sub interface, all and that. All of it.
Yeah.
Is it interesting? Switching.
It is very interesting. I think it's getting more and more difficult.
It's no problem, Clara, because you keep practice over and again. So I'm sure I think you can able to do it.
So can we go back to our lab?
You want me to go back to the lab? Okay.
Yes.
Okay. Yeah. Yeah, I opened the lab now.
Another switch
Hmm.
to the router and have another 2 VLANs to this side. Will there be communication from VLAN 10 to another VLAN 10 via the switch going that side?
Yes, I checked already. They have communication, see.
Sir, let's add another switch. Not that way.
Then
Add
how?
another device, another switch.
You want me to add another switch? Okay.
Yes. And let's add some endpoint devices.
Okay. Then you have to make trunk link. That's it. It will work. Here, what you have to do.
Let's connect that switch to the no. You should connect to the switch to the router, not to the switch.
You want me to connect to the router?
Yes.
Okay. Then
Yeah, let's make some configurations to this new network that I've created.
okay, what configuration you want me to? You want to what
The same as
configuration?
we did to this side.
Okay, this is gigabyte 0/1. So now you tell me what you want me to do here. I will do that. Is it you want me to create the same VLANs here?
Yes,
10 and
same
20?
VLANs. Yes.
Same VLAN?
Yes.
Okay. Okay, let's create this also belongs to same color, right? And this guy also belongs to same thing. So how they can communicate? See, so rather than first understand, Andrew, means you are wasting one port on the router because router is an expensive device. Already you have the other options. Okay, these gigabytes already we have created 2 sub interface, right? Understood?
Mm-hmm.
So
yes.
you want to communicate with 10 VLAN 10 and 20. So these people they can communicate to each other, right?
Yes.
And these people they can communicate to each other. This is your objective, right?
Yes.
No, his objective is correct. But what I am suggesting you for this, rather than doing this, okay, what you can do is, okay, just connect this trunk link.
Okay.
Make it this as a trunk link. That's it. It will communicate.
Okay.
No need to use this connection. Okay, so let's delete that. So let's put it like this back to that. So what I'm going to do, I will connect these 2 ports as a trunk link. 4.5 and 1.4. Okay, here what we have to do, we have to create the 2 VLANs, right? For the VLAN 10 and 20, right? And this is my VLAN 20 and this is my VLAN 20 and 10. Where is that? So what we have to do, just we create the VLANs here as well. Okay, so go to global configuration mode. So VLAN 10, name I'll give says VLAN 20, name I'll give HR. Exists. Just assign that ports. Which are the ports? I think 2 and 3. Okay, interface Fortinet 0/2. Okay, switch port mode access. Switch port access VLAN 10. And same thing, interface Fortinet 0/3 switch port mode access. Switch port access VLAN 20. Okay, now we can see show VLAN brief. We can see these two ports has been assigned to sales and HR. Right, so I'll go to this switch. I'll make this as a trunk link. Okay, so how we can make? Okay, so go to that interface, interface range, Fortinet 0/4 and 5. Okay, switch port mode trunk. Switch port trunk allow VLAN. Okay, VLAN all. Show interface trunk. So now these three, which are the port? 3 port has become the trunk link. Right, so 3 port has become the your trunk links. Now you check for the switch 2. So it's showing the message, right? So received the 802 BPDU on the non-trunking Fortinet ports for the VLAN 1. Okay, so show interface trunk. For 1 and 4 has become the trunk link now. Right, so let's assign the IP address for these. So what is the gateway? So 192.168 1 dot say I'll give 3 and IP address 192.168 1.10. And this is my 20 VLAN. So 192.168. This is 2.3. 192.168. This is 2.10. So let's check now. I think they should communicate, right? Now say green to green. Success. Correct? Green to blue, success. They can communicate, right? Andrew, can you see? Let's ping to 192.168. Say example 2.1, I guess. Yeah, you can communicate. See, and 2.10 for the router, we can reach. And this will become the one more lab now. This is one more lab, guys. You understood? Clara, Andrew?
Yes.
Sahil?
Yes.
Sahil? Sahil Gani?
Yes, understood.
Understood, right? And this will be
Yeah,
one more. Yeah, this will be, I'll make it save as now. So this is my inter-VLAN routing 3. No. You want this file also, guys?
yeah, do that. Same, please.
Same, no? Just add the switch. That's it, nothing else. If you want, I will send you, no problem. I think you can generate your this one, right? Commands, right? From your side, guys. Okay, just go and export. It will become the what are the command I used it. So all the commands will be available in your text file. You can able to open in your notepad. Right. Anyhow, I'm sending this one. You can download from your side. Okay, so let's jump for the next lab, guys. Okay, your next lab is your VLAN routing using SVI. SVI on layer 3 switch. Okay, so here this time I'm using layer 3 switch guard, that is a multi-layer switch. Okay, let me add on this dash. Okay, there is a multi-layer switch. So how do I do that? Okay, so what I'm going to do, so let's take my multi-layer switch. This is a multi-layer switch. Then I'll take my layer 2 switch. Okay, so whether we can use one or two. So right now, let me use only one. Okay, so you can use one or two, no problem. Okay, in this switch, what I'm going to do, so I will create the two VLAN inside here. So let's connect some end user devices. Okay, two PCs and two laptop. I see. So let's connect this. Okay, so here I'll connect one of the device. 5 and 5. So let it put some color. And this guy, I'll make it as VLAN 10. We can give any guys VLAN 10, 20, whichever you like. Okay. Don't think always you must use only VLAN 10 and 20. Don't be, it's not like that. Okay, so what is the first job we should do here? So using SVIs. So how we can do this lab? Okay, so first if we check in multi-layer switch guard, this is my multi-layer switch. This is, we'll call it as your layer 3 switch. Okay, if you type show VLAN brief, okay, so look like same that layer 2 switch, no difference. So no difference we can see here. So what I'm going to do here, the first thing is I will create the VLANs here in multi-layer switch. I will go to global configuration mode. So VLAN 10 and VLAN 20. Just I will get two VLANs, I'll not give the names. Okay. So what I'm going to do, I will give the IP address for these VLANs. Okay, how we can give the IP address? Say interface VLAN 10. Okay, then because as it is a layer 3 switch, we can give the IP address for the VLAN interface. Okay, so I'll give the IP address, say 192.168. This is sorry, IP address. So 192.168. Okay, say example 1.100. This time I will do changes. Yes, I say no check. Okay, and same thing for your VLAN 20. Interface VLAN 20. IP address 192.168. This is 2.100 and with a subnet mask. And say no check. Here you should type okay, IP routing. Issue this command IP routing. So now we can see check show VLANs. Okay, so we have created the two VLANs here. Right, so both are active. So we should assign the ports, right, for this. Okay, and now we have to enter. Sorry, I think we should create in here, man, not here. I think how to erase the configuration guard, right erase. So say configuration has been modified. Yes. Because I should create the VLANs in here, not there, in the multi-layer switch. Just create VLAN 10, okay, and VLAN 20. And assign the ports, as simple. How to assign, I think you know, right? So port number 1 and 2 will assign this thing. Okay, interface range for Ccna 0/1 and 2. Switch port mode access. Switch port access VLAN 10. Interface range for Ccna 0/3 and 4. Switch port mode access. Switch port access for the VLAN 20. Okay, show VLAN. Okay, so as per this thing, just we assign the ports VLAN 10 and 20. Check whether it is started. Show VLANs. Yes. So IP interface brief. Yeah. It is there. 2.1 around 1.1. This is the gateway for that. Okay, no problem. You understood that what I'm trying to explain you guys? So what I should do next, guys? What I did, just I created 2 VLANs here and assign the ports. Okay, now what we should do now? For the port number 5, I should make the trunk link, right? Understood? For this port, I should make as a trunk link. Correct? So let's do that, guys. So how I can do this? So go to global configuration mode. So interface for Ccna 0/5. Okay. Switch port mode trunk. Then that's it. Switch port
mode
trunk
allow
VLAN all.
Yeah.
That's it. So what about this multi-layer switch? We have to give here also. Show interface trunk. Here there is a no trunk. This one also we have to make trunk link, right? So now this guy has become a trunk. This guy has become the auto. So let's do that. So interface Ccna 0/1. Okay, switch port trunk encapsulation .1q. Switch port mode trunk. Okay, show interface trunk. Okay, now everybody has become the trunk link now. I think IP address, we have given the IP address for these things, for the multi-layer switches. Okay, so what is the next step, guys? We should assign the IP address for these ports, right? So 192.168, say this is 1.1. So 192.168, this is 1.100, correct?
Yes.
Yes.
Okay. And this guy is say 1.2, 1.100. This is 2.1, right? 2.100. Two dot three, 2.2, right? Okay, so I think as per our understanding, guys, I think they should communicate, right?
Yes.
Yes, so let's do that. So first packet will be dropped. Yes, perfect.
Yes.
We do have the communication now using SVI, switch virtual interface. So what configuration we have made? Show IP interface brief. So we have created the two VLANs here. For the VLAN, we have given the IP address, and this IP address acts as a gateway for these VLAN 10 and 20. So in this switch, what we configured? So we configured. Okay, so if you want, I'll paste you the command here also. Show run. Okay, see, these are the commands. I think what we did. So these are the MAC address he has learned from that other switch. So here what we did, we have created the two VLANs here. Okay, show VLANs. So we have created the two VLANs here, VLAN 10 and 20. Correct?
Where?
Then what we did, we make the trunk link. We assigned the IP address. That's it. Nothing else we did. Okay, this is called a switch virtual interface. Understood, guys?
Yes. Yes.
Yes.
Hmm. So can we move for next lab, or shall I continue tomorrow?
Yeah, before we proceed, I've got one question.
Yeah, Andrew.
If we can track the packets from PC0 to PC1, will the traffic go to the switch one, then switch 2? Maybe it will.
Yeah. I think you're talking about the trace route, right?
Yes.
Trace RT 192.168 2.2. See, is moving 1.100. First thing, first 1.100 means it's gateway. Through gateway is moving. Is coming here. You check here. So when you send, it will go to this gateway. So from this router, it will route to this PC. Same thing. Suppose if you check from here, the trace CRT, say 192.168 1.1. So it's going 2.1 and 1.1. Means always is communicating to this guy. So this guy is always, anybody ping me is coming to this way. Again is going this way. This way again is coming to this way. Maybe this side or that side. Okay, I think router on stick we did already. Okay, creating the two sub interfaces. I think we have done inter-VLAN routing using routers. Okay, so let me save this. Okay, this is inter-VLAN routing. SVI. I think commands you can take from your side, right? Or you want me to take the commands as well? Because if I send this file, you can generate, right? Go to option and preference and export. Just enable these logs. Okay, you can able to do that. Anyhow, so we'll do it. Understood, guys?
Yes.
I think you have received the files, right? 2 files just now I shared you.
Yeah, received.
Because I'm live in YouTube, guys. If anybody wants, they can watch it. Tomorrow also I will do the same thing. I'm available in YouTube live in your channel. They can watch directly from there. Okay, guys. I think now it is almost all evening here. I think it could be better tomorrow. I will start. Tomorrow I'm going to start with VTP and DTP, guys. These are the things. I think today, what are the things we did? I think we have done the basic one. Is a spanning tree, and these we'll do it tomorrow. And DR BDR election we have done, and trunking also we did, and intra-VLAN routing and router on stick. And we did 2 separate physical interface also. We can do this, no problem. Okay, so tomorrow we'll do VTP, this lab. Sorry, one more lab. I think dynamic trunking protocol. Okay. And after this, we will do that is per VLAN spanning tree protocol and rapid spanning tree protocol. So these 3 big lab, guys. Tomorrow we'll do. This is quite very important. Per VLAN spanning tree protocol and DTP, 3 labs will do tomorrow. Okay, and next Saturday, Sunday, so we will do the ether channeling. So ether channeling also, there is other name for this one. We'll also call the port channel. Port channel or ether channel. So in Cisco data center, we will call port channel. So these topics we shall discuss in your next Saturday, Sunday. Okay, if we have time, means we shall discuss some case study in real time next week. Case study. So before that, I think I told you that we shall discuss IPv6. Then we'll jump for these 3 labs tomorrow. And tomorrow, guys, please don't miss, because this is quite very important topic. Switching, this is very important. And next week, your port channeling, the ether channeling, layer 2 and layer 3. And this is the new CCNA syllabus, guys. In old CCNA, we don't have the layer 3 ether channeling. So latest CCNA, they have introduced layer 2 ether channeling. Okay. I hope, guys, I think today you learned something with me.
Yes.
Yeah, it was very helpful.
Very helpful, guys.
Mm-hmm.
I think today I went very slow because, like I'm fasting, in the Ramadan Kareem, right? Because now my body battery is low. Let me on my camera, guys. I think I didn't. Yeah, I think again people see, right? Let me stop my sharing. Battery is low, guys. My battery is very low. Right, guys. So I think today's sessions was very interesting, right? We did some spanning tree protocol, how to create the VLANs, how to assign the ports for the VLANs, how we can communicate intra-VLAN communications, what is VLAN, basic switching. Got it? Okay, so if you have any question, you can ask me, guys, before you wind up. We'll see you tomorrow. We can follow the same link, which I shared to you. Okay, tell them if they are unable to join, so if they can watch live on our YouTube channel. Anyhow, right now we are also we are live in YouTube channel, guys.
Okay, don't forget to share the link for today's lesson, video, I should say, on YouTube.
Yeah, video, because it will be live, because we can see. And just to go to the our YouTube channel, Sahil.
Channel.
Yeah, so we can see there.
All right.
Yeah, we can see this. Anyhow, because at the same time, I'll also upload this video.
All right.
Immediately, it's getting automatic. It will sync to the YouTube there.
All right. Don't forget to do that, please. I missed at least a big chunk of the lesson today. I had an internet issue today.
Okay, no problem. And please, friend, tell to your friend, guys, because next week is going to close this training. Next Saturday, Sunday will be the last. So, okay, tell to your friends if they're not unable to join, if they didn't got the link, okay, tell them so they can watch in YouTube live.
All right.
Just they need to subscribe our channel. If they subscribe, means then only they can able to see live. They will get notification. Okay, guys. Then see you then tomorrow. All
Okay.
the best. Take
See you
care.
tomorrow then. All right. Thanks. Bye.
Thank you, guys. Bye.